Chapter 9 is more of the same. Let's review chapter 8 in our heads at least. Chapter 8 was how to do hypothesis tests, knowing our 5 steps. We did tests about proportions, about means, and about standard deviations. Chapter 9 is tests about proportions and means and standard deviations, except that you're comparing 2 populations instead of 1. So instead of me saying the standard deviation is less than 22.5, I might say the standard deviation of this group is smaller than the standard deviation of that group. 2 different groups, 2 different samples. Other than that, it's the same kind of idea. So I don't know if you remember, when we started chapter 8, I said you're going to get really sick of hypothesis tests because that's all we're going to do for the rest of the semester. All it really is reading carefully what type of question you have, and then we're going through the same process. So I am moving on over to page 126. 126, where section 9.1 starts. Go ahead and read example 1 there before we go any further. Example 1, page 126.
So there's like 2 surveys instead of 1 survey?
Yeah, there's 2 surveys, he says. You see that? They surveyed people in 1993. They did another recent survey. You agree there's 2 different samples there?
Yeah.
And then the question is asking about comparing the 1993 students to the current students. So we see how there's 2 populations there? That's what makes it a chapter 9 problem. And to organize everything, I like to take the initial step of defining which population is which. Is it men and women? Is it race car drivers and non-race car drivers? In this case, what are my 2 groups they're talking about?
1993 and then.
Just different years?
Yeah, the 1993 students,
And then 2017.
and we'll just put recent students. I don't know, did it say 2017?
No, it doesn't. It says recent. It just says
Recent, we'll put
recent.
recent. Maybe it was last year or something. It's important to define which one is which, because I might say I think number 1's bigger than number 2. Well, which one's number 1? You need to know which group is which. Or if I say number 2 is bigger than number 1, depending on how you define them, you might say it differently, so it's important to know which one is which. Most of us will label them in the order that they're given to us, but it doesn't have to be. All right, so those are just defining my 2 groups. Based on that, let's talk about some of the numbers we had that came with it. This is organized what they tell us. What did they tell us about these 1993 people? They gave us an N and an X, right? They told me how many people and then how many said yes. So for this group, what was N?
560.
560.
And 171.
And 171 of them said they used illegal drugs back in 1993. And then for this group, they took a different sample size, because it was a completely different survey. And they surveyed 720 college students. And 263 of them said they used illegal drugs. Just organizing what they gave me. The question says, use a 0.05 significance level to test the claim that the proportion of college students using illegal drugs in 1993 is less than it is now. How do I write the proportion? What letter do I use?
P.
P. And because they're talking about the proportion of students in this group, I'm going to call that P1. The proportion for group 1. So what's my claim? P1 is
Less than E2.
less than E2. The proportion from 1993 is less than the proportion from recent years.
So We have the complement would be P1 equals P2.
So up here would be P1 equals P2. And those are my H0 and my H1. Same rules apply. The equal sign goes with H0. Make sure you know which one is your claim. So chapter 9 adds this new element where all of a sudden you have to know which group is which and what are we claiming about the two different groups. It's important that I know that number 1 is the 1993 people because this wouldn't have made sense if I had labeled them differently. Which group are we saying is smaller, right? So you have to make sure I know which is which.
So 2 props.
Kevin's already working ahead, I hear him back there. We're okay with stating the claims? So then our choice is to either use this messiest formula we've seen yet,
That's right.
or go to 2 prop Z test, which makes sense. We have 2 proportions in this claim. So we're gonna go in and do a 2 prop Z test.
Well, so 1 and 2.
Let's talk about what it asks for. First, let's make sure we can find it.
X1 and N1 and
It asks for X1 and N1,
X2 and N2.
X2 and N2, and then it asks what the claim is, right? And then you would choose the less than claim? Yes.
How do you know how to use 2 prop Z tests and 2 prop Z?
If it's asking you to test a claim, you're gonna do a 2 prop Z test. If it's asking you to find an interval, then we would do int for interval. We're gonna get there next. We haven't done the intervals yet. But in this case, we're doing a test.
Same. Damn.
Everyone okay? And then we actually have all this information. The X and the N from the first group. So that was our 171 and the 560. And then the X and the N from the second group. So we're typing all that into our calculator to get the test statistic, and this function gives us our p-value as well. So here's step 1. Once you typed all that in, you should have your test statistic. What is it?
Negative 2.25.
It's a z. Negative 2.25. We getting that? I got lots of silence, makes me nervous.
Yeah, it's it.
That's what, okay, Brian agrees. A couple more people nodding. What do I want for step 3? P-value, I've got it right in front of me, right? Remember the calculator just calls it P.
0.01.
0.01?
Less than alpha.
That's less than alpha, he says. Alpha was over here. So our conclusion about H0, reject H0. Which means we have sufficient evidence.
Support.
Hang on, let me go back and look. I don't remember which one was our claim. Okay, I agree with them. Because we're rejecting H0, has every problem today been rejected?
Yeah.
We've got to find one that's failed to reject eventually. Because we rejected H0, we're supporting our claim? We support this guy? To support the claim that, and now we're just going to restate the claim, which was the proportion of college students using illegal drugs in 1993 was less than it is now. I didn't hear you said, Frank.
So I wonder what it is today.
Wonder what it is today. Well, we can estimate that. When you got your Z on your screen, you still have that screen handy, did it give you a P1 hat and a P2 hat?
Yeah.
Let's talk about those. What was P1 hat?
0.305,
And what was P2 hat?
0.365.
So this is just from the sample, but around 30% of people back in 1993 said yes to this question. And now it's around 36% that said yes to this question. Now, that's not an exact number, that was just from your sample. We'd have to get a confidence interval to get a range, but clearly this is higher than that,
So it is upward trending.
an upwards trend. We could also argue, if you read the problem carefully, it's not that they used illegal drugs, it's that they said they used illegal drugs.
Oh,
Oh, so
Got
that's
some
dishonest.
liars.
Hey, maybe these people back in 93 were like less likely to admit it, and now they're just more likely to admit it? I don't know, I would argue that it didn't say that they actually used them, it said they said they used them. I saw a hand over
Do you
here.
have to write, what did you do there?
For here, where, right?
Okay, yeah, fine.
No, we were just discussing the difference between them.
Okay, that's fine.
You don't need them, it's just discussing the difference between them. Because that's really what the test is all about. We see that these proportions look different. The test ran the whole thing to show, yes, they really are different. Because they may not be exactly the same, and the question again is, are they different enough? Yes, Kirsty?
When we're writing out the hypothesis, can, instead of just writing the whole thing out, or the conclusion, I'm sorry, when we're writing the conclusion, can we put what the claim was rather than write the whole thing out?
Because the conclusion is the only piece of information you're going to share with the public.
Oh.
So here you are, someone's hired you as a statistician, 'cause that's all what you've always wanted to be, and so someone hired you to test what's going on with students and drug use. You need to be able to come out to the public and say what you found. I found that I've got sufficient evidence that supports that, they use less drugs, or they say they use less drugs now.
So they just want layman's terms for like
Yes.
the conclusion?
Mhm.
Okay.
The conclusion is what you're going to tell the people who don't even know any stats. That's really what it is. Nobody, I don't like to write them either. I'm just saying, but we have to write them because that's the whole point of the test. Other comments or questions? Okay, so here's where chapter 9 gets a little bit trickier. They throw in not only tests, but confidence intervals in the same chapter, which is actually right underneath the problem we just did. Look at example 1b. It says test the above claim using the appropriate confidence interval estimate for the difference between the proportions. So the important thing there is it says to do a confidence interval. I'm going to draw a picture first. This is for 1b. Was this test we just did a one-tailed or a two-tailed?
One-tailed?
It was a one-tailed, right? It was a left end? So if I had wanted to find the critical values, you don't have to. I would have had to find something over here. I would have to look for that number right there if I was looking for a critical value. What's the area in that tail?
0.05.
0.05.
0.05 was our significance level?
Yeah.
0.05? Now, if I wanted to make a confidence interval, I have to have it balanced when I'm doing a confidence interval. There's always two tails. So here's the trick. I have to create this new tail that's the same size. I have to create another tail. I have to create a matching tail. The reason you have to have two tails is confidence intervals, remember, always goes a little bit down and a little bit up. So if you're trying to find a confidence interval, we have to create this other one. Yes?
When do you use a sleeve instead of this one?
Put some more words in that question for me. When do you use this instead of that?
So that's two, okay, this one, that one goes like this, and the other one has a 0. How did you know which one?
The one that starts with 0 is the chi-squared,
How did you know to use that?
because that goes with standard deviations. And when you look on your sheet here on page 2, it tells you that if you're doing a test about standard deviations, it shows you there's a chi-squared there. Here we had z's, two props z's. So everyone understand what I mean about creating a matching tail? Yes.
I was just gonna say, like, an easy way to clear up when to use with the chi-squared and stuff is just looking at the formulas, and
Mhm.
saying that there's no sigma in the hypothesis testing with two proportions.
Mm-hmm.
So that would be,
Right, the only time we use the chi-squared is when we're doing tests or confidence intervals about one standard deviation. The only time.
the standard deviation would be the
Mhm. So I created this other matching tail. How big is it if it matches?
Would it be the same? Or would
It'd be
it
the same if it's matching, right? That's another 0.05. So here's my question for you then. What's my confidence level? What's in between there? What'd you say? 90.
Yeah. 90,
Well,
because you
Because I got 5 over
Oh,
here,
yeah.
and I got 5 over here.
Yeah.
You agree there's a 90 in here?
Mhm.
So I want to find a 90% confidence interval. So this is a little bit tricky. When you do a confidence interval tied to a test like we just did, you have to sometimes create another tail to figure out what your confidence level is. It's not just 1 minus alpha.
When
What?
you say sometimes, is that just because it's not a two-tailed test now?
Yes. If it was already a two-tailed test, I wouldn't need to come up with another tail. I already would have two tails.
Right.
But in this case, because I had a one-tailed test, I had to kind of create this extra one over here to figure out what would have been in the middle, to keep it balanced. So now I want to find a 90% confidence interval. Look what it says. The confidence interval for the difference between the proportions. Confidence interval for the difference. In proportions. What does difference mean? Subtract. The proportions we're talking about, remember, are still the same P1 and P2.
So would you just subtract it?
So what we're finding, I'm going to actually write it up here so you can all see it. We're talking about P1 minus P2, the difference between them. I want to leave those there because we're getting a confidence interval. Kind of like when we looked here. The difference here was around 6%. You agree that difference was around 6% difference? This one was 6% lower than that one. But that was just from our sample, so we want a range of values. So what we do when we want a confidence interval, instead of a test, we do a 2-prop z int. See where it says int at the very bottom of the page?
Mhm.
So this was testing a claim, now we're doing an interval. So we're going to go in and do 2-prop z int. And here's the really good news. Your calculator is so darn smart, it's just hanging on to the information you already typed in a minute ago over here. Aren't your x1 and your n1 all in there already? So what's the only thing you have to add?
The 90.90.
The sea level has to be 90. 0.90.
So I got the numbers right.
You got some numbers? Tell me what you got.
I got a negative 0.1035 and a negative 0.0164.
We're going to interpret that in a minute. Did we get those same numbers as him?
No.
I'm going to change those into percents because talking about them makes more sense with percents. Technically, that's my confidence interval.
Negative 10%?
Yeah.
Or,
Negative meaning it's lower.
oh,
So I'm going to actually interpret it in a second here. So this is 10.35% and 1.64%. I'm just turning them into percents because I can talk about it easier when I use words. So this is telling me that if I subtract my two proportions, because remember these are proportions from the samples. If I knew what they were for the whole population, this tells me that I'm subtracting, I'm getting a negative answer. What do you know about numbers when you subtract them and you got a negative answer? Like, give me two numbers that when you subtract, any two numbers, when you subtract and the answer is negative. 1 minus 2, she says. Give me another example that we subtract.
4.
1 minus 4,
No, 3 minus 4.
3 minus 4,
0.
0 minus, what'd you say?
Anything.
99. These are all negative answers. Why?
Because it's not 0.
Aha, the first number is smaller. When you subtract and get a negative answer, it's because the first number was smaller. So I'm subtracting these proportions, and I'm getting negative answers somewhere between here and here. Which means that this number must have been smaller than that number. What do these numbers represent?
The percentage?
The percentage or the proportion of students who used illegal drugs in '93 must be smaller than the ones who used it in recent years. And this tells me how much smaller. Somewhere between 1.64% smaller and 10.35% smaller.
That's quite a bit.
Quite a bit. It's a range though, because we don't know what it is exactly. So the proportion, I can't spell it right now, of students using illegal drugs in 1993 is 1.64% to 10.35% lower than it is now. Let me move out of the way and make sure you can read that.
Would that be like a step one?
That would kind of be our step 5, interpreting it. Why do I say that it's lower? Because they're negative. When I'm subtracting two numbers, it's either negative, somewhere between negative this and negative this. So it's definitely lower. No matter what, I'm getting a negative answer. We agree it's lower? What would the numbers have looked like if it was higher? What'd you say? They wouldn't have been negative. We would have had positive numbers here. It would have been this much to this much higher. And next time we'll talk about, well, what if one's negative and one's positive? We'll talk about that next time. So we didn't finish 9.1, don't panic. If you looked at our schedule for today, we were starting 9.1, we're gonna finish it next time. You might want to start thinking about it because we're gonna do a lot with the intervals and the tests. Interpreting the intervals is tricky for a lot of us. Head to the lab if you want to do the lab with me. If not, I'll see you next time.